Okay, Bismillahirrahmanirrahim. So today will be our 16th lecture, and today, okay, let me first share the screen. Okay, so today we start from article number 8.4, hard and soft magnetic materials. So first of all, we'll learn what is called hard magnetic materials and what is called soft magnetic materials. So basically, if we start from 8.6.1, so how to identify the soft and hard magnetic material. So based on their BH behavior, so you know about the BH loop or the hysteresis loop, which one is commonly known. So based on this BH behavior, the engineering materials can be classified into two categories. They are the soft and the hard magnetic materials. So what is called soft magnetic materials? If their BH hysteresis curve is narrow, if their BH hysteresis curve is narrow, then that one is known as soft magnetic materials. If the hysteresis curve is not narrow, look, we know about this hysteresis curve, right? So this one is known as BH curve. So if this BH curve is larger, then that material is known as hard magnetic materials. If this BH curve is not larger, that means narrow, then that one is known as soft magnetic material. So you know for which property that one is becomes narrower, or for which property that one becomes wider. So basically these things depends on the capacity of that particular material. That means the uh, capability of magnetizations and demagnetization. Okay, so these things. Let us learn some applications. So for the soft magnetic materials, this one is basically used for some typical applications for the repeated cycle of magnetization. That means the magnetizations and demagnetizations, these two things are repeatedly recurred. For this case, we need the soft magnetic materials. Say for example, the electric motor, transformer, or and also the inductor. Because for electric motor, this one varies cyclically. So these applications requires low hysteresis loss, right? So next one will be the hard magnetic materials. So for the hard magnetic materials, it requires the magnetization and demagnetization. Uh, it requires more time, right? So for example, this one is actually used for the communication materials. Okay, so you know in the I think I do not need to describe these things about this BH curve. Okay, so please go through this thing. Next one is article number 8.6.2. That one is the initial and the maximum permeability. Okay, so look, if we want to identify the value of this mu r, that one is the relative permeability. That one equals to B divided by mu naught H, right? So basically, this mu naught value is a constant value, but actually these things depends on the applied field. Okay, so how to find out this initial and the maximum permeability? Look, we can identify this initial and maximum permeability from the BH curve. So look, initial permeability or initial uh, curve, that one starts from zero, right? So initially we considered that the materials is initially demagnetized. That means it doesn't have any magnetic properties. So whenever we insert this material into a magnetic field, then that one start from zero, right? So from zero, this curve start rise up. Then after that, this curve generate this hysteresis loop. So what is called the initial permeability, that means we have to draw a tangent starting from the origin zero to the curve of that initial curve. Then this one is known as the from this slope, the value of this slope will give us the initial permeability. Now, what is called the maximum permeability? So, similarly, we have to draw the tangent starting from this origin to the last point, or this last adjacent point of that particular curve is from this tangent. If we find out the slope, then we can find out the maximum permeability. So, what you know about the slope? I do how to identify the slope. So, slope means the positive angle that one is uh, formed along with the x-axis. So, if we can find out this tan theta, so that one will give us the slope. So from there we can find out the maximum permeability and also the initial permeability. Okay, I think this one is clear. Now move to the article number 8.7. So this article is basically a very theoretical things, not theoretical things. That one is application based thing. That is the soft magnetic materials, examples and the uses. So, from our previous sections, we have learned which one is known as the soft magnetic materials and which one is the hard magnetic materials and the difference in between them. So, in this case, we will learn the example of soft magnetic materials. So, an ideal soft magnetic materials would be a zero probability. That means the Hc and a very large saturation magnetization. That means B saturation. What is called desaturation? So, ideal soft materials. That means these things should be this ideally this H value in this x direction. This H value should be near to zero, and this B value should be near to the maximum value. That means as narrow as possible. That one is the magnetic materials, right? Okay. So, if we there are a few examples. That one is the nickel iron alloy. That one that its composition is 77%. So I am requesting all of you, please go through this thing. This one is a very easy things as literature type things, and here you will find a table. So from this table you will understand based on these values what is the applications and what are the different types of magnetic materials. Okay. So next one will be the amorphous magnetic materials. So in this case, you will find there will be some combinations of the metal. That means the if you look, that one is the nickel will be 79% and the iron will be 16% and 5% cobalt. Now, one of the very important thing, that one is the ferrite magnetic materials. So ferrite magnetic materials is basically used in high frequency applications. Okay. Now, try to solve the example number 8.6. Next, move to article number 8.2. Okay. So, in article number 8.2, that one is the hard magnetic materials and the examples and uses. So, similar type of things. So, which one is called hard magnetic materials? So, hard magnetic materials means the BH value, the area under this BH curve should be maximum. In that case, that one will be the hard magnetic materials. So there are some examples of hard magnetic materials. So please try to go through these theoretical things. So I think no need to memorize these numerical values. Just understand which magnetic materials are used in where. Just try to go through this thing. Okay. So from here you will find another concept. That one is the single domain fine particle. So I think this won't be very difficult for you. If you go through these things, you will understand this word. Okay. So mostly the literature part. So I think you can go through this part by yourself. I'm requesting all of you to go through this part. Next, try to solve the example number 8.7. Okay. Now this will be the end of our hard and soft magnetic materials part. So here I would just like to conclude the uh, portion of uh, magnetic properties of the material. So in our next lecture, we will learn about the superconductivity, and that will be the last lecture. Okay. So thank you.